Hello everyone, welcome to this tutorial. In today's lesson we're gonna see how to find problems like this one, sine cos inverse of 12 over 13. So it's expected to find the exact value without using tables and calculators. In place of theta, for example sine theta, we know how to find this, but in place of theta, what if it is inverse functions like cos inverse of 12 over 13, sec inverse of. So we will do this exercise. Okay, let's gonna start. The first question is to find the sine of cos inverse of 12 over 13. For those kinds of problems, to make it simple, let the inner part, this one, as theta or any other variable you can define. So let this inner part as theta, so theta will be cos inverse of 12 over 13. As we see in previous lessons on inverse functions, this means the same as find the value of theta so that its cos value is 12 over 13. So we can rewrite this as cos theta equal to 12 over 13. We know that cos theta is defined by the definition as adjacent side of a right angle triangle over the hypotenuse of a right angle triangle. So from that definition we can draw a right angle triangle whose adjacent side is 12 and whose hypotenuse side is 13. Then we will find the remaining opposite side from Pythagoras theorem, since adjacent square plus opposite square equal to hypotenuse square from Pythagoras theorem. Thus, using Pythagoras theorem, we can find the remaining opposite side of the right angle triangle as this hypotenuse square minus this adjacent square. So 13 square minus 12 square, it is 169, minus 144, it is radical 25, which is 5. So after getting this value, we can find any trig value for theta. For example, the sine theta is opposite over hypotenuse, cos theta is adjacent over hypotenuse, sec theta is, for example, hypotenuse over adjacent, and so on. So we can find any value from a right angle triangle after drawing it. So in our case, the question is to find sine. So sine theta will be the same as opposite side, it is 5, over its hypotenuse side, which is 13. So sine theta will be 5 over 13. What is this sine theta? Is the question to find sine theta? What is theta? At the beginning of our solving this problem, we let this theta by cos inverse of 12 over 3. So theta means cos inverse of 12 over 13. Thus, this sine theta can be written as, or it has the same value as sine of, in place of theta, it is cos inverse of 12 over 13. So finding sine of cos inverse of 12 over 13 will be the same as finding sine theta. Thus, the value of sine cos inverse of 12 over 13 will be 5 over 13. This way, we can find any trig value which have an inverse function in place of theta. Let's move on to the next question. The next question is to find the tan of sec inverse of 10 over 6. So we let this inner part by theta, and from the definition it means that find the value of theta so that its sec value is 10 over 6. We know sec is hypotenuse over adjacent because it is reciprocal of cos function. So sec is 10 over 6, it means hypotenuse over adjacent, so its hypotenuse is 10 and its adjacent is 6. Draw a right angle triangle so that it fulfills this value, and then we will find the remaining side, which is opposite side from Pythagoras theorem, as 10 square minus 6 square, which gives 8. Then After drawing this right angle and finding the remaining angle, we can find any value of trig value for theta. For example, in our case, it is expected to find tan of theta. So tan of theta means it is opposite side over adjacent. Its opposite side is 8 and its adjacent is 6, so 8 over 6. As we know, theta is defined by sec inverse of 10 over 6, so tan theta is the same as tan of sec inverse of 10 over 6. Then the value of this value is the same as tan theta, which is 8 over 6. The third question is to find a cosec of cot inverse of 3 over 4. So as usual, let this inner part by theta, and after define this from the inverse function, it means cot theta will be 3 over 4. Cot is defined by adjacent over hypotenuse, so draw a right angle triangle which have adjacent side of 3 and opposite side of 4, so which is theta for theta, so its opposite side is 4 and its adjacent is 3, so we can find the remaining this side by Pythagoras theorem as 3 square plus this 4 square, which gives radical 25, which is 5. So after that we can find any value. For our case, it's expected to find the cosec value. We know that cosec is defined by hypotenuse over opposite, which is reciprocal of sine function. So hypotenuse over opposite, its hypotenuse is 5, its opposite side is 4, so we can find that, and as usual substitute theta back, and cosec or cot inverse of 3 over 4 will be 5 over 4. The next question is to find cot of sine inverse of 8 over 10. So let this inner part by theta. So from the definition of inverse trigonometry, sine theta will be 8 over 6. So this means the same as sine theta. Find the value of theta so that its sine value is 8 over 10, so sine theta is 8 over 10. Sine means opposite over hypotenuse, so its opposite side 8 and the hypotenuse side 10, so we will draw the right angle triangle and we will find the remaining side. The remaining side is adjacent side, so this adjacent side will be hypotenuse square minus opposite square, which gives 6. After that, we can find any trig value. In our case, it is expected to find the cot of this theta. So cot means adjacent over hypotenuse. So its adjacent side is 6 and its opposite side is 8. So it will be 6 over 8. Thus, substituting theta back by sine inverse of 8 over 10, it is the same as cot of sine inverse of 12 over 8 over 10, which this value is 8 over 10, not 12 over 3, which gives 6 over 8. This is incorrect notation. Okay, the fifth one. The fifth one is to find cos of cot inverse of x. So as usual, let this inner part by theta, and so this means find the value of theta so that its cot value is x. So cot means the same as adjacent over opposite. So this one from inverse definition, it means cot theta will be gives x. So x it's the same as x over 1. So find the value, draw a right angle triangle which have adjacent side of x and opposite side of 1. Thus, drawing adjacent side by having x and opposite side of 1, we can find the remaining hypotenuse side from Pythagoras theorem as radical of x squared plus 1 squared, which gives radical x squared plus 1. Then, for this value of theta, we will find cos. So cos theta will be the same as its adjacent side is x over radical x squared plus 1. so x over radical x squared plus 1. So substituting this cot inverse of x in place of theta, which gives cos of cot inverse of x, will be the same as cos of theta, which gives x over radical x squared plus 1. The last question, but not the least one, is to find sec of tan inverse of 1 minus x over 1 plus x. So let the inner part this by theta, so theta is tan inverse of 1 minus x over 1 plus x. It means the same as tan of theta gives 1 minus x over 1 plus x. Thus, tan theta is defined by its opposite side over adjacent side. So draw a right angle triangle which have opposite side of 1 minus x and adjacent side of 1 plus x. Therefore, using Pythagoras theorem, the hypotenuse will be the same as 1 minus x squared plus 1 plus x squared under square root, which gives square root of 2 into 1 plus x squared. Then it is expected to find sec of theta. So sec of theta is defined by hypotenuse over its adjacent side. Its hypotenuse side is radical 2 into 1 plus x squared, and its adjacent side is 1 plus x. Thus sec theta will be this value. Therefore, substituting this tan inverse of 1 minus x over 1 plus x in place of theta gives this one, sec of tan inverse of 1 plus x over 1 minus x, which is the original question, and which have the same value of sec theta, which will be 2 into 1 plus x squared over 1 plus x. So for any value of x, you can find sec of tan inverse of this value. Thank you for listening. If you are new, please subscribe. Okay, goodbye.